Hi friends, see yesterday in part 1 electrostatics, while the chapter is going to end, a small correction is there actually. I have to edit and I have to post, but due to time lag I have not edited that one. Small mistake has done in the last part. Let me correct that one and then I will go to the part 2 of electrostatics today. So you can see on the board, in the last part 1, small mistake was done, that is when x is equal to infinity, that means when this distance you have seen this ring, uniform ring. So in uniform ring you have seen a point P at a limited distance, that means when at a limited distance, this is the formula for electric field intensity, and at the center when x is equal to 0, what happens? Inside no field, therefore E was 0. Actually in overlook what I have told is in part 1, please excuse me for that one, I told at x is equal to infinity, I told E is equal to infinity, please sorry for that one, it is not infinity, because when x is going to infinity, more distance, this charge becomes point charge. Then the equation becomes like this, E is equal to kq by x square. So what happens? When x is very large distance, what happens? Charge becomes point, then E also becomes 0. So please correct that one. It is not infinity, please. E is also 0. That was the correction I want to tell in part 2. First you correct that one. Okay. So at x is equal to 0 center and at x is equal to infinity, E is equal to 0. Only at the middle part, x is equal to, for example, plus r by 2 and minus r by 2 only, the values are there. Okay. This is the solution. R by root 2 and minus r by root 2 is the solution for this one. Electric field intensity. Kq x by x square plus r square power 3 by 2. So, okay. So, I think you will be correcting that small point. At x is equal to center, E is equal to 0. At x is equal to infinity, E is not infinity, please. It is E is equal to 0. Because when you go more distance, E becomes very less. Charge becomes point charge. Very point charge. Therefore, what happens? E becomes 0. Only at the middle the values are there as maximum r by root 2 and here negative r by root 2. Clear? Right. Now let us go to the next item in this version. I told you I will be telling more important about that is charged particle, that is motion of a charged particle. That was the next one I want to tell for you. Please note down. Motion of a charged particle. That means already yesterday I have discussed what will be the force acting on the particle placed in electrical field. Now suppose if it is freely falling, అంటే కిందకి స్వేచ్ఛగా పతనం అవుతున్నప్పుడు, just like in kinematics, whatever equation you have used, now we will be using the same equation. Now the question is motion of the charged particle, please. This is part 2 of electrostatics. Electrostatics part 2. Okay, still we are in electric charges and fields. Ending part. Still we are electric charges and fields. Okay. So here what you are going to tell is motion of the charged particle. Already I told you, suppose if a particle is having mass m, okay, this is the field I told you, electrical field, opposite force is acting, this is weight, okay, I think I have given charge plus q charge there, okay, I have given plus q charge there, force is acting in this direction opposite to the field, EQ, therefore EQ is equal to mg. This EQ sometimes is also written as EE, because E is the charge of electron. Okay, so E is equal to m into g, or from this EE by m is also equal to g, equation 1. Now what I am going to tell is motion of the charged particle. Suppose this particle is freely falling. So when freely falling, we already know in kinematics S is equal to ut plus half gt square, freely falling. A is equal to plus z, u is equal to 0. So in this, what is the height? 2h by g under root is equal to t. So for this, the time taken t is given by root over 2h by g. What is g value of the particle? Charge particle? G, E by m. M will go to the top. So this is the time taken for the charge particle to fall freely. Time taken. That is 2 height, m is mass of the particle, E charge of the electron, 1.60 to 10 power minus 19 coulombs, and E is electric field intensity. Okay. So this is how you have to calculate the time for freely falling of the charged particle. Okay. Now let us go still further. Okay. Let us go still further in this electrostatics. Now we are going to talk about electrical field lines. Just like magnetism lo, magnetic field lines chadivi untaru meeru. So let us see what are electrical field lines. Okay. So we know, for example, if you take a isolated positive charge. So for isolated positive charge, always it goes away from the, you can see, this is how the electrical field lines are going away from positive. In the same way, if you take negative charge, it comes towards. Okay, these are the field lines. In negative charge, if you observe carefully, it is coming towards. This is positive charge. Okay, this is negative charge. Now, in the same way, if you take two positive charges, okay, so positive charge ఏమవుతుంది వెళ్ళిపోతుంది కదా. Okay, so these are the field lines for the positive charge. Okay, goes away for two positive charges anamata. Okay, two positive charges if you take, what happens? They'll go away, please, because two positive repel each other. So the field lines are going away from the positive charge. You can see goes away. Okay, clear? In the same way, if you take for one positive and one negative, ఇప్పుడు ఏమవుతుంది? పాజిటివ్ నుంచి నెగిటివ్ వైపు వస్తుంది ఛార్జ్, అలాగే నెగిటివ్. Okay, positive to negative and negative charge towards the negative charge it will be coming. Okay, positive to negative, you know the field lines, and no field lines will intersect each other, because if they intersect each other, the resultant will be in two directions, which is highly impossible. So these are the field lines. You can see positive charge నుంచి వెళ్ళిపోతుంది, negative charge వైపు వస్తున్నాయి, అలాగే two positive charges going away. Okay, one positive, one negative going away and coming near. Okay, in the same way you can take the last version, two negative charges. So these are the field, electrical field lines. These are the electrical field lines for isolated positive, isolated negative, or positive positive, positive negative charges. Now in the last case, if suppose if you take two negative charges, if you take two negative charges, what happens we'll see. Two negative charges. Okay, so two negative charges. Negative charge ఏమవుతుంది? Comes towards kada. Negative charge comes towards. Positive charge go away. So towards. Okay, negative charge comes towards. So these are the field lines for negative charges. You can see, you can draw as many number of lines. Negative charge, the lines are coming to the charge, positive charge going away. Okay, for negative charge, lines are coming towards the charge. These are the properties. They are coming towards the charge. You can see the arrow marks. And for positive, going away. So these are the electrical field lines representation for electrical charges. For positive, positive, negative, positive, and two negatives, one positive, negative. And no two lines will intersect with each other because each lane is distinct. If they intersect, the resultant has to be in two different directions, which is highly impossible. Okay? Right. Now, let us go and try to understand what is electrical dipole. Another important concept. Already in magnetism also I told you, I will be telling in next chapters, coming chapters. Same things again will be repeating here. See, I told you before also, in magnetism and electricity, both have same points and both have same terms. Only literature will be different. Now, what is electrical dipole moment or electrical dipole? Electrical dipole అంటే ఏంటి ముందు, and thereby dipole moment, and thereby electrical dipole moment. We'll try to understand. See, already we studied in the dynamics and other things, couple two equal and unlike forces acting on a body which is producing torque. Before chapters you have studied, okay? In angular momentum, two equal and unlike forces acting on a body at different points constitute a couple. So here electrical dipole means, see, one is negative charge, another is positive charge. And as I told you, from positive charge field will be going away and from negative charge it is coming towards. But in electrical dipole, always the moment will be from negative to positive. Okay? So, and generally, in general, distance and this one will be taking as 2a or 2l. Just like your magnetic length. Magnetic length 2l, either you can take 2l or 2a. 2a or 2l, generally the length. Distance between minus charge and plus charge. Clear? Now, here what is happening here? For example, if you put this one in some electrical field direction, suppose this axis is making an angle some theta with the field, electrical field. Okay? Suppose this is minus and this is plus q, and the distance of separation I am telling either 2a or 2l you can take. Now what happens? This will try to align in the field, that is the property. It will be stable there in the field. And a torque is trying to act here. So electrical dipole mundu enti tarvata torque ento study chedam. Electrical dipole means, see, minus charge and plus charge, and mean two equal and unlike charges. Two equal and unlike charges separated by distance 2a. So P is equal to 2aq. This P is a vector quantity. P and D, vector dipole, electrical dipole moment. This is a vector quantity. It has both magnitude and direction, just like magnetic moment. Product of pole strength and length. ఇక్కడ కూడా అంతే. Product of charge and distance. అందుకే దీని SI units కూడా coulombs meters. What is SI unit? Coulomb into meter. So it is a vector quantity, please. Vector, both magnitude and direction. It is given the product of the length, distance between the charges into the charge, 2aq, and it is vector quantity, dipole, electrical dipole moment. Now suppose if these two charges are separate distance 2a or 2l, placed in electrical field, ఏమవుతుంది దీని మీద? It will try to align in that position. Torque will be acting here, torque. So here if you observe in this direction, one force, F is equal to minus eq. Okay, in this direction F is equal to plus eq. Okay, minus charge here, but we will take magnitude, please. I won't use minus. If you take magnitude, you can omit the minus value. So ఇటు పక్క force ఏమో eq, అటు పక్క force eq ఏమవుతుంది? దీని మీద torque. So what is the torque here? Force into perpendicular distance. So suppose if you take this as a perpendicular distance, what if this is angle theta? Opposite by hypotenuse. Same name some letters A, B, C. Opposite by force into perpendicular. What is the force here? Force into perpendicular distance is equal to torque. So torque is equal to, what is force there? EQ. EQ into what is this perpendicular distance? theta ki ఏ side? Opposite side. Okay? So 2a sin theta. Opposite by that is 2a sin theta. But you know what is 2aq? P. So torque is equal to E P sin theta. Clear? See one formula you got now? This is torque acting. Okay? So torque is given by EP sin theta or PE sin theta. Here E and electric field intensity, P is electrical dipole moment, sin theta is the angle. Okay? So when theta is more, suppose if theta is equal to 0 degrees. Theta 0 and అర్థం ఏంటి? This expression also you can write it in vector form. Torque, I told you it's a vector quantity kada. You can write in a vector form. P cross E. Torque acting here can be represented as P cross E, mod P, mod E into sin theta. Here P is what? Electrical dipole moment, E is electric field intensity. Adotna make point? Here this is what? Electrical dipole moment. Units and coulomb meter. Coulomb meter into electrical field intensity. Electrical field intensity 2 units ఉన్నాయి దానికి. F is equal to EQ లోంచి న్యూటన్ పర్ కూలుంబ్ ఒకటి, ఇంకోటి V is equal to ED నుంచి మరో ఫార్మ్ ఉంది, వోల్ట్ పర్ మీటర్. ఎనీ యూనిట్ యూ కెన్ యూజ్, either you can use Newton per coulomb or volt per meter or volt per meter. If you use volt per meter, meter gets cancelled. Okay, so you can use any unit. చూడండి P unit ఏంటండి? What is the P unit? Coulomb meter కదా. I'll write it here. Coulomb meter into, suppose if you write volt per meter, E unit. But meter cancel అయ్యేది coulomb into volt అవుతుంది. Coulomb into volt. లేదా if you don't want to keep like this, you can also use this one. Coulomb into meter into Newton per coulomb. Because F is equal to EQ. So coulomb can in Newton meter. And you know that is the standard unit for torque. Force into perpendicular distance, Newton meter. So any unit, SI unit you can use for torque. Now what we'll do, we will comment on for what angle it is maximum torque and minimum torque. Okay? Let us go for that one. Next one. Clear? Now we will try to understand what will be the maximum value and minimum value. What are the diagrams for that one? We will try to draw clearly. See, torque will be maximum, minimum. You can calculate in this fashion. See here. Torque will be maximum. See here. Torque maximum. ఎప్పుడు అవుతుంది? Suppose you know theta is equal to 90 degree. Sin 90 is equal to 1. Okay na? అంటే ఏంటి? Torque is equal to PE sin 90. So torque is equal to PE న్యూటన్ మీటర్ మ్యాక్సిమం. అంటే అర్థం ఏంటి? ఒకసారి ట్రై చేద్దాం. నౌ సీ దిస్ ఈజ్ యువర్ ఫీల్డ్. ఓకే, నౌ ఫీల్డ్ డైరెక్షన్కి పెర్పెండిక్యులర్ ఉండాలి. అంటే ఎలాగా చూడండి. యాజ్ ఐ టోల్డ్ యూ, దిస్ ఈజ్ మైనస్ క్యూ, దిస్ ఈజ్ ప్లస్ క్యూ. సో మైనస్ నుంచి ప్లస్ వెళ్తుంది కదా డైపోల్ మూమెంట్ పి, వెక్టార్ క్వాంటిటీ ఇది కూడా. సో అబ్జర్వ్ కేర్ఫుల్లీ హియర్, వాట్ హ్యాపెన్స్? Minus q is plus q. What is the angle between them? 90. This is also vector. So when theta is 90, you can see both are perpendicular to each other. Electrical dipole moment and E. So sin 90 is 1. Therefore torque is equal to maximum. ఇంకో కండిషన్ ఏంటి? maximum torque చెప్పగలరా? We'll draw that diagram also. ఇంకో కండిషన్ ఏంటి? For example, this is electrical field. Suppose if you put like this, what happens? నెగిటివ్ టు పాజిటివ్ వస్తుంది ఇక్కడికి. ఓకే, నెగిటివ్ అప్పుడు 180 డిగ్రీ అవుతుంది. సైన్ 180 ఏమవుతుంది? 0 మళ్ళీ, బికాజ్ 90 ప్లస్ 90 కాస్ 90. సో అలా కాకుండా ఐ ట్రై టు పుట్ ఇన్ దిస్ ఫ్యాషన్. See here, I will put here minus q, here plus q, and we all know from minus to plus electrical dipole. This is electrical dipole moment. చూడండి ఇప్పుడు ఇది 90, ఇది 90, 180 and 90. So what is the total angle? 270 degrees. So again, when theta is equal to 270 degrees, see, forget about the minus here. ఎందుకంటే మీకు ఆ డౌట్ రావచ్చు, సార్ sin 270 degrees sin 180 plus 90 కదా, థర్డ్ క్వాడ్రంట్లో tan theta cot theta పాజిటివ్ కదా, నెగిటివ్ కదా మీకు రావచ్చు. ఎస్, ఓకే, ఈ వాల్యూ sin 180 plus theta is sin 90, థర్డ్ క్వాడ్రంట్ మైనస్ ఏ, బట్ ఐఎమ్ టేకింగ్ మ్యాగ్నిట్యూడ్. మ్యాగ్నిట్యూడ్ తీస్తే పాజిటివ్ అవుతుంది. సో అగైన్ అది కాకుండా అగైన్ సే అగైన్ ద యాంగిల్ బిట్వీన్ ద E and P again 90 degrees. So in 270 degrees and 90 degrees, torque is maximum. I am forgetting, you see, don't take minus here please. I am taking magnitude. ఎందుకంటే ఇక్కడ ఇది వెక్టార్ కాబట్టి మ్యాగ్నిట్యూడ్ తీసుకుంటాం. మ్యాగ్నిట్యూడ్ తీసుకుంటే ప్లస్ అయిపోతుంది. సో అట్ థీటా ఈజ్ ఈక్వల్ టు 90 and 270, టార్క్ ఈజ్ మ్యాక్సిమం. ఓకేనా? రైట్. నౌ లెట్ us go for మినిమం. మినిమం ఎప్పుడు అవుతుంది చూద్దాం, టార్క్ మినిమం. దెన్ వీ కెన్ గో ఫర్ న్యూమరికల్స్ ఆఫ్టర్ దిస్ వన్. So let us study when torque is minimum. Otherwise, the point minus don't consider that because you are taking magnitude, vector kabatti. So let us see now when torque is minimum. So torque formula enana P sin theta. Theta is equal to 0, 180 degrees. చూడండి ఒకసారి. So torque is equal to PE sin 0, 0. అలాగే torque is equal to PE sin 180 degrees. sin 180 అంటే ఎంత చూడండి, sin 180 అంటే sin 90 plus theta. sin 90 plus theta అంటే ఏంటి, సెకండ్ క్వాడ్రంట్. సో cos 90 0, సెకండ్ క్వాడ్రంట్ కదా, cos 90 0, ప్లస్ మైనస్ పక్కన పెట్టేసాడు, ఈవెన్ దో సైన్ ఈస్ పాజిటివ్ హియర్. సో టార్క్ ఈస్ 0. సో when the angle between the electrical dipole moment and electrical field becomes 0 and 180, అంటే for example, this is electrical field and suppose this is the direction. For example, this is minus and this is plus. This is electrical dipole moment vector. See here, P and E same direction. So here what happened, theta 0. Next, electrical field intensity. Now see here, minus Q plus Q, this is the direction of vector. Now you can see what is the angle between this P and E. So here theta is equal to 180 degrees because angle between P vector and E vector is 180 degrees here. Ikkada angle between P vector and E vector is 0 degrees. So in such cases, torque is minimum. Clear? See, this is how you have to understand the subject. Then only later on you can do some numerical problems. Okay? Now we will try to do one numerical and again we will go back to the concept. Because electrostatics, if you don't know the concept, you cannot understand the subject. Subject is very, very easy only, but try to understand the concept. Now I am giving a small numerical for you and then we will go back to the next concept. Small numerical in enter, see here. Here two charges are given for you. One is QA and one is QB. ఆ రెండు చార్జెస్ కూడా ఎలా ఉన్నాయంటే ఒకసారి చూడండి. One is 2.5 into 10 to the power minus 7 coulombs. Okay. One is plus, and because these are forming electrical dipole. Another is minus coulombs. Minus 2.5 10 power 7 plus 2 point QA and QB. And their positions are given. First one is at the position 0, 0. Coordinates are given minus 20 cm. Second one is also 0, 0. I think it is 20 cm, centimeters. So the coordinates of the two charges are given. దీన్ని బట్టి మీకు అర్థం చేసుకోండి, ఇది x కోఆర్డినేట్, y కోఆర్డినేట్, z కోఆర్డినేట్, x కోఆర్డినేట్, y కోఆర్డినేట్ and z కోఆర్డినేట్. అంటే these two charges are on z axis because x coordinate, y coordinate 0 ఎప్పుడు అవుతుంది? See, if any body is on x axis, y coordinate is 0. If any body is on y axis, x coordinate is 0. If any body is on z axis, అప్పుడు ఏమవుతుంది? రిమైనింగ్ కోఆర్డినేట్స్ విల్ బి 0. మీకు అర్థమవుతుంది కదా, x కోఆర్డినేట్ ఉంటే y కోఆర్డినేట్, z కోఆర్డినేట్ 0. జెడ్ కోఆర్డినేట్ మీద ఉంటే యాక్సిస్ మీద ఉంటే జెడ్ యాక్సిస్ మీద ఉంటే ఏమవుతుంది, XY కోఆర్డినేట్ 0. సో ఇక్కడ మనకి ఇచ్చాడు వాడు ఏంటంటే చార్ట్ చూడండి. I'll draw the figure for you for understanding better manner. Let this is be Z axis. Let this be X, Y axis. This is the origin, 3-dimensionally. 3 are perpendicular each other. So one is at -20, another is at 20, plus 20. And another is -20 and another ఏంటి, ఒకటేమో కింద ఉన్న పాయింట్స్, ఇంకోటి ప్లస్. సో హియర్ క్యూబీ ఉందన్నమాట చార్జ్. క్యూబీ ఎంత, -2.5 10⁻⁻1 కూలుమ్. దీని కోఆర్డినేట్స్ ఎంత, 0 0 20 cm. పాజిటివ్ జెడ్ యాక్సిస్ ఇది, ఇది నెగిటివ్ జెడ్ యాక్సిస్. అలాగే ఇది పాజిటివ్ ఎక్స్ యాక్సిస్, ఇది నెగిటివ్ ఎక్స్ యాక్సిస్. This is I cap, unit vector. This is minus I cap, negative x axis. అలాగే y, positive j cap. This is negative y axis. Y dash, this is minus j cap. అలాగే ఇది k cap, positive, and this is minus k cap. So this is how you can represent in vectorial form. అయితే ఇక్కడ కోఆర్డినేట్స్ QB ఎక్కడ ఉంది, పాజిటివ్ జెడ్ వైపు ఉంది. QA ఎక్కడ ఉంది, QA ఎక్కడ ఉంది, +2.5 into 10⁻⁻1 కూలమ్స్ ఎక్కడుంది, 0 0 -20 cm, నెగిటివ్ జెడ్ యాక్సిస్లో ఉంది. మీకు అర్థం పాయింట్, జాగ్రత్త చూడండి. ఇదేమో ఒకటేమో -20 ఇచ్చాడు, -20 అంటే నెగిటివ్ జెడ్, 0 0 బికాజ్ ఇట్ ఈస్ లయింగ్ ఆన్ ద జెడ్ యాక్సిస్. ఇంకోటి ఏమో ఎక్కడుంది, 0 0 20, 0 0 20 ఇక్కడ ఉంది. క్లియర్? ఫస్ట్ డ్రా ద ఫిగర్. ఎనీ డౌట్ యూ విల్ సీ. సో ఇది ఫిగర్ ఎలా ఇచ్చాడు. ఇప్పుడు వాడు ఏమడుగుతాడు, మీకు ఈ డిస్టెన్స్ ఇచ్చాడు, మీకు జెడ్ డిస్టెన్స్ ఇది 20 centimeters. X కోఆర్డినేట్, Y కోఆర్డినేట్ 0 బికాజ్ ఇట్ ఇస్ ఆన్ X జెడ్ యాక్సిస్. X కోఆర్డినేట్, Y కోఆర్డినేట్. అలాగే ఇది కూడా ఈ డిస్టెన్స్ ఎంత, magnitude, please don't take negative, magnitude 20 centimeters. So what is the total distance? Because these two are equal and unlike charges, separated by distance how much? See, we know formula P is equal to 2aq kada, vector, electrical dipole moment. So dipole moment అంటే ఎలా వస్తుంది, 2a distance of separation, 20 plus 20 how much, 40 cm. Convert into mks divided by 100. Okay, 2a కదా, అంటే this distance plus this distance 20 plus into q charge. చార్జ్ ఏంటి, వాల్యూ ఎంతైనా తీసుకోవచ్చు. 2.5, don't take minus because 2 equal unlike charges, 10⁻⁻7. మీకు పాయింట్ అర్థమవుతుందా మీకు? తర్వాత ఇక్కడ చాలా జాగ్రత్త గుర్తుపెట్టుకోవాలి. కోఆర్డినేట్స్ అయితే రాస్తాం మనం. ఇది పాజిటివ్ సైడ్ ఉన్నాయి కోఆర్డినేట్, ఇది నెగిటివ్ సైడ్ ఉన్నాయి. కానీ పాజిటివ్ సైడ్ కోఆర్డినేట్ దగ్గర ఛార్జ్ ఎంత ఇచ్చాడు, నెగిటివ్ ఇచ్చాడు. సో నెగిటివ్ వాల్యూ, నెగిటివ్ కోఆర్డినేట్ సైడ్ ఇది ఉంది. అంటే మీకు ఇందాకే చెప్పాను ఎలా వెళ్తుంది ట్రావెలింగ్, -q +q. ఎక్కడి నుంచి వెళ్తుంది, డైపోల్, -2 ప్లస్. ఎక్కడ ఉంది మైనస్, ఇది మైనస్ ఛార్జ్. సో dipole moment will be like this, in this fashion. That means from positive to negative z axis. So therefore ఈ వాల్యూ ఎంత అవుతుంది, 0 0. ఓకే, 2 2s are 2 5s are 5 1s are 5 5s are by 10 ఇక్కడ పాయింట్ ఉంది కాబట్టి 5 5s are 25, 5 1s are 5 2s are 2 2 క్యాన్సిల్, ఎంత, 10 to the power of -7 కూలుంబ్ మీటర్ డైపోల్ మూమెంట్ కాబట్టి. సో వాల్యూ ఏంటి, 10 to the power -7. ఎక్కడి నుంచి వెళ్తుంది, మైనస్ ఛార్జ్ టు ప్లస్ ఛార్జ్. ఇది మైనస్ వాల్యూ, ఇది ప్లస్. సో పాజిటివ్ జెడ్ టు నెగిటివ్ జెడ్. సో వాట్ ఇస్ ద డైరెక్షన్? Direction is 10 to the power of -7 negative z axis, that is minus k cap. So this is the value, dipole moment. Like this you have to solve the problem. చూడండి ఎంత అందంగా చేస్తాం ప్రాబ్లము. You have to draw very neatly figure first of all, then only you will get the equation. As I told you, always moment will be going from negative to positive. ఇందాక కూడా చూపించాను. ఇక్కడ ఇది నెగిటివ్, ఇది పాజిటివ్. నెగిటివ్ ఎక్కడ ఉంది? పాజిటివ్ సైడ్ ఉంది, z axis. So from there the direction is there. So from negative z to positive z to negative z. So minus k cap. Okay, please note down. Let us go to the next one. Clear? Right. Now let us go forward still further. Are you understanding the subject here, electrostatics? Very easy subject. Just now I told you, if you understand the subject, it is very easy. Electrostatics. Now one more problem I'll do and then I'll go to the next concept if you want. ఇంకొక ప్రాబ్లం ఉంది, I'll give you that one. ఇంకోటి ఏంటంటే చూడండి, another numerical. These are the axes given x by origin. Now they are given some points as like one is 2q, ఇక్కడ 2q ఇచ్చాడు ప్లస్ q, ఇక్కడేమో మైనస్ q ఇచ్చాడు, అలాగే ఇంకోటి మైనస్ q చార్జెస్ ఇచ్చాడు. ఈ డిస్టెన్స్ ఇచ్చారండి మీకు, ఇది 2a అట, అంటే కోఆర్డినేట్స్ ఎంత 2a, 0, అలాగే ఇది కూడా 0, 2a. ఓకేనా, 0, 2a అంటే x కోఆర్డినేట్, y యాక్సిస్ మీద x కోఆర్డినేట్ 0 కదా, అది 0 కోఆర్డినేట్, ఇక్కడ y కోఆర్డినేట్ 0. సో ఈ డిస్టెన్స్ ఇచ్చాడు మీకు. సో మనం ఏం చేయాలి, దీనికి డైపోల్, నెట్ డైపోల్, వి వాంట్ నెట్ డైపోల్, p నెట్, నెట్ డైపోల్, ఎలక్ట్రికల్ డైపోల్ మొమెంట్. సో ఎలా వస్తుంది మీకు, ఇక్కడ ప్లస్ 2q ఇచ్చాడు కాబట్టి లెట్ us divide into two forms. Let us divide into two forms. మైనస్ q ఒకటి, ప్లస్ q ఇంకోటి, మళ్ళీ ప్లస్ q మైనస్ q. Distance 2a and here distance again 2a. So here if you observe carefully, minus నుంచి ప్లస్ వెళ్తుందని చెప్పండి డైపోల్. This is p1. Again minus to plus వెళ్తుంది, this is p2. So in vector represent, if you represent, one is coming down p1, okay na, one is coming down p1, negative to positive వెళ్తుంది dipole moment, అలాగే another is coming this fashion p2. So p1 and p2 are having an angle 90 degrees. So this is p net. This is p net. And what is the formula for electrical dipole? 2a into q. Okay, 2a into q. What is the distance? 2a. Distance between the anything, you can take any two charges, 2a. 2a into what is the charge value? Q. So therefore dipole moment P is given by 2a into capital Q. So what will be this net? Net ఎప్పుడు కూడా రెండు ఈక్వల్ ఫోర్స్ ఉన్నప్పుడు ఏమవుతుంది వాల్యూ? √2 into F అని చెప్పాను కదా మీకు ముందు న్యూటన్స్ లాస్లోని. When two equal forces are acting, what is the value? √2 into F. What is F here? The net value. That is 2a into Q. So this is the net electrical dipole moment. So two forces, because it's a vector, this is also two dipole moments, electrical dipole moments. One is the down direction and in this direction. So when those two are acting at right angles, parallelogram you can apply. Root over p1 square plus p2 square, p1 p2 cos 90 degrees. So √2 into 2aq. So this is how you have to solve the problems. Now let us go to the next one. Clear? Right. Now let us understand how to find. I won't derive this one because mainly we are concentrating on MSET and NEET examinations. So derivations maximum I will be avoiding. If required only I am deriving the derivations. So first case ఏంటంటే ఇప్పుడు on axial line. On axial line. What is axial line here? See, this is north pole, south, east, west. That means, for example, this is one charge, another charge. This is the direction of dipole moment. Axial line ante idi anamata. Idi point. Point parallel to east west of there. This is axial line. So now at this point P, I want electrical field intensity. Just like in magnetism, magnetic field intensity B or induction. B alagayithe kanuko ikkada kuda alage kanukovali. Derivation I am not doing because time factor, but mainly we are concentrating on the MCET examination and NEET exam. Therefore, directly I will give the formula and I will explain how, in what fashion it is coming. So, axial line lo E kavalante, first try to understand the concept. E distance already I told you 2a, and this is center portion A, this is A. Let this distance be some r, this point P, location at r or L or whatever D, whatever distance. Now, such cases what happens, మీకు చెప్పాను, పాజిటివ్ చార్జెస్ నుంచి ఫీల్డ్ ఎటువైపు ఉంటుంది? దిస్ ఇస్ డైరెక్షన్. పాజిటివ్ చార్జ్ నుంచి ఫీల్డ్ ఎక్కడ? గోస్ అవే. ఫీల్డ్ మీకు ఏం చెప్పాను మొన్న ఎక్స్ప్లెనేషన్లో, ఫీల్డ్ డైరెక్షన్ ఎప్పుడు కూడా ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ గోస్ అవే ఫ్రమ్ పాజిటివ్ చార్జ్. అదే నెగిటివ్ ఛార్జ్కి అయితే కమ్స్ టువర్డ్స్. ఓకే, towards negative charge, it comes towards negative charge and goes away from the, and already we have given the equation also, E kq by r square, where k is 1 by 4 pi epsilon naught in free space, and q. Okay, suppose if you are considering here as 1 coulomb unit charge at P point, then what will be the intensity here? Intensity formula ఏంటండి? K into Q by D square or R square. So K into Q in this direction. If you want, you get like this, K into Q at this point. Q and ఏంటిది? Q, small q. Don't write plus minus here because it is field intensity. It is not electrical potential. See, potential energy ఒక్క దగ్గరే మైనస్ వాడతాం, ఇంకెక్కడ కూడా మనం మైనస్ వాడడం. And repulsion or attraction, we will write the actual value only. Because you are already telling it is attraction, repulsion. You need not write minus and plus signatures there, signs. So kq by d square. So in direction lo, ఇది ఎంత అవుతుంది distance between these two? R minus a. And what is this distance? R plus a. If you look at like this, you can calculate kq by r square and r minus a whole square. Equation 1. Alage second one, electric field towards positive charge. Positive charge అయితే అవే వెళ్ళిపోతుంది, నెగిటివ్ చార్జ్ towards. సో ఇప్పుడు E2 ఎంత అవుతుంది? అగైన్ kq by distance whole square. Equation 2. Now tell me from mathematics, out of these two which is greater? Denominator is greater కదా, ఇక్కడ denominator is less. ఎవరు denominator ఎక్కువ ఉంటే ఆ వాల్యూ తక్కువ ఉంటుంది. So this value is more, E1. So E1 is greater than E2. So subtract from that one. E net is equal to E1 minus E2. Okay na? So E1 minus E2. This is what? E net. Clear? Simple formula you are using, that's all. Take LCM. Take kq common outside. Okay, ఇది ఎంత అవుతుంది? A minus b whole square, a plus b whole square, 4ab. Okay, ఇది ఎంత అవుతుంది? R minus a whole square into R plus a whole square. పైన ఏమో R plus a whole square, ఇక్కడ R minus a whole square. A plus b whole square minus a minus b whole square, 4ab. సో పైన ఇక్కడ ఎంత అవుతుంది? I'll write it here. Okay, so this is how you have to solve it. Intensity, electric field intensity, very easy one. The thing is you have to understand the concept here. So ఇక్కడ ఎంత అవుతుంది అప్పుడు? kq into 4ab by a plus b into a minus b, a square minus b square, a square minus b square. See, in some books they are using length L. Here I am using R. In some books they are using L. ఏదైనా ఒకటే అండి, R బదులు L యూజ్ చేయొచ్చు, ఎనీథింగ్, బట్ ఐఎమ్ యూజింగ్ here R here, and this distance as A. Therefore a square minus b square whole square. So జాగ్రత్త అబ్జర్వ్ చేయండి ఇక్కడ ఈ నెట్ on axial line is equal to kq and this one 4 and 2 into 2 RA by r square minus a square whole square. So E net on axial line is equal to K. What is 2 A Q? Dipole moment, electrical dipole, that is P. Okay? This 2 A Q dipole, ఇంకోటి ఉంది 2 R ఇక్కడ by r square minus a square whole square. And K, you know, 1 by 4 pi epsilon, constant value. అదవుతుందా? ఈ r అంటే నథింగ్ బట్ ఇదిగోండి ఈ డిస్టెన్స్ r. దీన్ని మనం చాలాసార్లు అంటే డిస్టెన్స్ బిట్వీన్ ద మిడ్ పాయింట్ అండ్ దట్ పాయింట్. నేను ఇక్కడ 2a వాడాను, కొంతమంది 2l వాడుతున్నారు డిస్టెన్స్, ఏదైనా వాడుకోవచ్చు. ఓకే, అది యూ కెన్ యూజ్ 2a ఆర్ 2l. క్లియర్? సో ఇక్కడ ఈ ఫార్ములా గమనించండి చాలా జాగ్రత్తగా. వాట్ ఈస్ ద వాల్యూ గాట్ ఫైనలీ ఈ నెట్ ఆన్ ద యాక్సిల్ లైన్? 2kp into r by r square minus a square whole square. This is E net for axial line for long dipoles. Long dipoles. For long dipoles. For long electrical dipoles. మీకు అర్థమవుతుందా? For long electrical ఏంటది? 2kpr. 2kpr by r square minus a square whole square. సపోజ్ ఎగ్జామినేషన్లో షార్ట్ అడుగుతాడు డైపోల్, అప్పుడు ఈ క్వశ్చన్ మళ్ళీ అంటే ఈ ఫార్ములా మారిపోతుంది. ఫర్ షార్ట్ డైపోల్ వాట్ హ్యాపెన్స్? అగైన్ యూ హావ్ టు సాల్వ్ ఇట్. సీ హియర్. ఫర్ లాంగ్ డైపోల్స్ యూ కెన్ యూజ్ దిస్ ఫార్ములా. లాంగ్ డైపోల్స్. ఫర్ షార్ట్ డైపోల్, ఫర్ షార్ట్ డైపోల్ అర్థం ఏంటి? మీరు డిస్టెన్స్ తీసుకున్నారు కదా d. దిస్ d ఈజ్ వెరీ మచ్ గ్రేటర్ దాన్ వాట్? ఏ. ఇది చూడండి ఒకసారి, ఇది మైనస్ క్యూ కదా, ఇది ప్లస్ క్యూ. ఈ డిస్టెన్స్ ఎంత అనుకున్నారు? 2a. ఎక్కడెక్కడో తీసుకుని d. ఈ d కంపేర్ విత్ దిస్ a వాట్ హ్యాపెన్స్? వెరీ మచ్ లార్జర్ దెన్ a ఆర్ ఎల్. సో అప్పుడు ఏమవుతుంది? ఇక్కడ చూడండి, కామన్ తీసుకోండి. 2kp vector r by, I can take common here, r square into 1 minus a square by r square whole square. So if d is very much greater ఏమవుతుంది? If d is very much greater ఏమవుతుంది? ఇక్కడ ఇది d అంటే ఏంటి? ఇక్కడ r ఏంటి? మనం ఏం తీసుకున్నాం? d తీసుకున్నాం, a తీసుకున్నాం. సారీ, ఇక్కడ డిస్టెన్స్ d కదా, ఇక్కడ r. ఇక్కడ if r is very much greater, please see r తీసుకున్నా, ఇక్కడ d కాదు. if r whatever distance is there, the center point నుంచి, okay, see in the diagram I have given d there, this distance d, that d is nothing but r, please. So if d is equal to r is very much greater than a, చూడండి అప్పుడు ఏమవుతుంది? if this value, denominator value is very much greater than a, ఏమవుతుంది? a square by r square is very less value, is less value. If this value is very much large, a square by r square ఇంకా less అవుతుంది. అప్పుడు you can omit this equation. అప్పుడు ఏం మిగిలింది? r power 4. So 2kp vector r by r power 4, 1 r, this cancel. So finally 2kp by r cube. This is the formula for short dipoles on axial line. Therefore only ఒకటే డెరివేషన్ మీకు చేశాను మీకోసం. రిమైనింగ్ నెక్స్ట్ I'll give direct formulas, please. So electric field on axial line intense is equal to 2 constant k 1 by 4 pi epsilon naught dipole moment by r cube or d cube. d అయితే d వాడుకోండి, r అయితే r వాడుకోండి, ఏదైనా ఒకటే ఇక్కడ మీకు. ఓకే, సో దట్ ఈస్ ద ఫార్ములా ఫర్ షార్ట్ వన్, 2kp by r cube. Clear? Please copy it. We'll go to the next one directly. Here derivation I won't do now, directly I'll tell you. Akkada please make a note. I have written d there in the diagram. If you want to take d without d you can take r. d badu r తీసుకోండి please. Then only this will satisfy here. Okay? Now second one, due to equatorial line. Due to equatorial line. Equatorial line తెలుసు కదా? This is north and south, east, west. Parallel to north, south. అంటే ఇది minus q plus q distance. ఇక్కడ 2a అనుకున్నాను, అక్కడ 2l అనుకుంటారు, చూసుకోండి. 2a ఈ సెంటర్ పాయింట్, దిస్ ఇస్ ద పాయింట్ p, ఈక్వటోరియల్ లైన్. సో ఈ డిస్టెన్స్ నేను d అనుకున్నాను. యూ కెన్ టేక్ r ప్లీజ్. d అయితే d or r అయితే r, ఎనీథింగ్ ఇస్ రైట్. సో హియర్ ద పాయింట్ ఈస్ దేర్ నౌ. సో ఎట్ దిస్ పాయింట్ వాట్ హ్యాపెన్ హియర్? పాజిటివ్ ఛార్జ్ నుంచి అవే, ఫ్రమ్ పాజిటివ్ ఛార్జ్ ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఏముంది అవే, అలాగే నెగిటివ్ ఛార్జ్కి ఎలక్ట్రిక్ ఫీల్డ్ 2 watts. So these are E1 and E2, this will be the resultant. So this is E net please, and you can see E net is in opposite direction of axis. So here the value you are getting negative value please. చూడండి ఒకసారి, this one is in that direction away from the positive charge and towards the positive charge. So E net is in negative x-axis, so negative value you will be getting here. So E net in this case, equatorial line is got by minus kp bar by r cube for short dipoles, for short electrical dipoles please. అదే లాంగ్ కావాలనుకోండి ఫార్ములా మారిపోతుంది. ఫర్ లాంగ్కి హియర్ ఐ రైట్ హియర్ ఈ నెట్ ఫర్ లాంగ్ డైపోల్స్ మైనస్ అలాగే ఉంటుందండి, పి కూడా ఉంటుంది పైన, కిందన డి స్క్వేర్ అంటే ఆర్ స్క్వేర్. ఒరిజినల్ ఫార్మ్ మీకు తెలుసు కదా, అక్కడ డి స్క్వేర్ ప్లస్ ఎల్ స్క్వేర్, ఓకేనా? ఆర్ స్క్వేర్ ప్లస్ ఏ స్క్వేర్ పవర్ 3/2. సేమ్ మ్యాగ్నెటిజంలో ఫార్ములాస్ ఇక్కడ కూడా రిపీట్ అవుతాయి, అర్థవుతుందా? సో ఇఫ్ యూ టేక్ కామన్ హియర్ అవుట్ సైడ్ వాట్ హ్యాపెన్స్? అగైన్ ఆర్ స్క్వేర్ కామన్, 1 plus a square by r square, okay? Take this one common here, power 3/2. So once again r very much greater than r, ఇది r, ఇదిగోండి ఇది r, when r is very much greater than d or a, అదవుతుందా? లేదా d ఏదైనా అనుకోండి, ఇక్కడ నేను ఆర్ని డి అనుకోవచ్చు, లేదా డీని ఆర్ అనుకోవచ్చు. బట్ వెన్ ఆర్ ఈజ్ వెరీ మచ్ గ్రేటర్ దెన్ ఏ ఆర్, కొన్ని పుస్తకాలు వెన్ ఆర్ ఈజ్ వెరీ మచ్ గ్రేటర్ దెన్ లెంత్, ఏదైనా ఒకటేనండి ప్లీజ్, డోంట్ కన్ఫ్యూజ్ ద లిటరేచర్ హియర్, ఎనీథింగ్ ఇస్ రైట్. వెన్ దిస్ డిస్టెన్స్ ఇస్ వెరీ మచ్ లార్జ్, అగైన్ దిస్ ఈక్వేషన్ ఇక్కడ ఉంది కదా కామన్, ఈ ఈక్వేషన్ పోతుంది ఆర్. అప్పుడు ఏముంది పైన ఆర్ స్క్వేర్ పవర్ 3/2 ఆర్ క్యూబ్ ఉంటుంది, అంటే మైనస్ కేపీ బై ఆర్ క్యూబ్ వచ్చింది కదా. సో దిస్ ఈజ్ ఫర్ లాంగ్ డైపోల్స్, మైనస్ కేపీ వెక్టార్ బై ఆర్ స్క్వేర్ ప్లస్ ఏ స్క్వేర్ పవర్ 3. ఆర్ ఈస్ ద డిస్టెన్స్, దిస్ వన్ ఆర్ ఆర్ డి. ఏ ఆర్ ఎల్ ఈస్ ద డిస్టెన్స్ బిట్వీన్ ద 2 charges, ఓకేనా? క్లియర్? సో దిస్ ఈజ్ ఫర్ లాంగ్ అండి, ప్లీజ్ మేక్ ఎ నోట్. మైనస్ కేపీ బై ఆర్ స్క్వేర్ ప్లస్ ఎల్ స్క్వేర్ ఆర్ ఆర్ స్క్వేర్ ప్లస్ ఏ స్క్వేర్ పవర్ 3/2. Clear? And for short, minus kp by r cube. Clear? Right. So sometimes in the examination he may ask in this fashion also. Elanti chudandi, relation between axial and equatorial line. Relation chudandi, for short magnet, not long magnet, for short magnet, for short electrical dipoles, relation between E axial and E equatorial line. So E axial ఏంటి మనకి 2kp vector by r cube, short axial, E axial. అలాగే E equatorial ఏంటి? E equatorial minus k by r cube. సో జాగ్రత్త అబ్జర్వ్ చేయండి, ఇది జాగ్రత్త అబ్జర్వ్ చేయండి. ఈ యాక్సియల్ I can write as 2 times of what is kp by r cube, E equatorial. Of course minus పక్కన పెడదాం, దాకా take magnitude, minus pakan I take a magnitude. So E axial is 2 times equatorial, you can see. 2 into Kp by R cube. So axial line electric field intensity ఎంత ఉంటుంది? 2 times the equatorial line intensity. This one you can use as a corollary for the examination as a bit question. E axial is equal to 2 times equatorial line. And we have one more formula, please, for the electrical dipole at any angle. At any angle. And for example, minus Q plus Q are there separated by 2L or 2A distance. Okay. Suppose this is, say, some angle. At some angle it is there at point P. Electrical dipole moment direction P vector. Okay. And this is what? The component P cos theta. And this is the vertical component P sin theta. So this is axial line. Okay. See here, P cos theta and P sin theta having two vectors here. Please observe carefully. At any angle I am trying to give the formula. Okay na? This is P sin theta, this direction, equatorial line, and this is axial line. This is axial line and this is equatorial line and okay? This is axial line. This is equatorial line. And this is P net. And let this angle be some theta or alpha. Alpha this one. Because already it is theta here. So this is P net. This is equatorial line. Now this is axial line. So suppose in such cases if it is given, then E, electric field intensity E is given by at any angle. ఇంతవరకు axial line equatorial line చూసాం. ఇలా ఉన్నప్పుడు at any angle E is given by Kp root over 1 plus 3 cos square theta by, of course, R cube. Okay na? R cube. R cube. So this is a generalized formula which is got by these two vectors. చూడండి ఇది P sin theta, ఇది P cos theta. Okay na? Axial line, equatorial line. By using the geometry, trigonometry, you can get this formula. I am not deriving. Okay? E at any angle Kp by R cube into root over 1 plus cos. చెక్ చేద్దామా? ఈ axial నాకు కావాలి. ఈ ఫార్ములా కరెక్ట్గా చెక్ చేద్దాం. ఈ axial line కావాలి. ఎంతో చూద్దాం ఆగండి. రూట్ ఓవర్ 1 plus 3. ఈ axial line ఎక్కడ ఉంది? చూడండి ఈ డైరెక్షన్లో ఉంది. అంటే యాంగిల్ ఎంత? థీటా. థీటా ఈజ్ ఈక్వల్ టు 0 degrees. అంటే పిఈ సేమ్ యాంగిల్ కదా. పి అండ్ ఈఆర్ సేమ్ డైరెక్షన్. సో కాస్ 0 ఎంత? 1. సో దేర్ ఫోర్ కేపీ బై ఆర్ క్యూబ్ రూట్లో 3 plus 1 4. రూట్ 4 ఎంతండి? 2. సో 2 kp by r cube. చెక్ చేసుకోండి. 2 kp by r cube axial line. 2 kp by r cube for short magnet. This is what? 2 kp by r cube for short dipole moment. In the same way, if you want equatorial line, put 90 degrees there. Equatorial line. For equatorial line, put theta is equal to 90, cos 90 is 0, root 1 1. So what happens? Minus అలాగే మనం పెట్టుకోవాలి, అందులో రాదు. B bar by P bar by R cube. Or sometimes he may give some 30 degrees or 45 degrees. Put the value here and calculate the field, electric field intensity E bar. So this is the generalized formula, very 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 important. Okay, please make a note of that one. Clear? So these are the things about electrical dipole moment, torque minimum, torque maximum, electric field intensity on the axial line, equatorial line, and also at any angle by giving some formula, that is Kp by R cube root over 1 plus 3 cos square theta. Okay, clear? Now let us go still further. That is, for example, this is electrical field direction. Suppose this is a electrical field direction. Now in this, for example, as you know, 2a distance or 2l distance, okay, it is placed at some angle, for example, theta angle. Now I told you in this direction force F is equal to minus EQ, and this direction F is equal to, and the torque will be acting and it will try to align along the direction of the field, okay, and it will try to stable. Suppose if slightly it is moved for small angles, then it will make SHM, then it will be making simple harmonic motion for small angles, okay. So then what we have already, we know T is equal to 2 pi and root over L by G for simple pendulum. But in this case what happens, time period of electrical dipole is given by 2 pi and root over, in the place of length I, in the place of G, magnetism lo aithe I by MB, ikkadaithe P. This is the formula. In magnetism, I by MB, M is magnetic dipole, here M place lo P, electrical dipole, B magnetic field induction, ikkada electric field intensity. So this I is moment of inertia, please. I is moment of inertia, mass into square of the distance. This is the time period for the electrical dipole, which is making small angles and making simple harmonic motion in the field. Moment of inertia by electrical dipole, electrical field, 2 pi constant, T is time period, please. Clear? Now, let us go to the non-uniform field. What happens? Next case, non-uniform field. See, till now we are studying about uniform field, uniform electrical field. Now, for example, if you take non-uniform electrical field, non-uniform electrical field, and uniform ga ledu maarutundi. Appudu em javutundi chuddam. For example, this is a charge plus Q, okay. So you can observe here it is a non-uniform field, okay, in this direction, non-uniform electrical field. So in such cases, for example, so electrical dipole, for example, is present, minus Q plus Q separated by distance D, okay, uniform kaadu, non-uniform. So non-uniform lo emavuthundi ikkada meeku, there will be E variation, field is not uniform, E is varying, okay. So since E is varying, what happens? There are some points here you have to note down, please note down. Torque on the dipole, it is already I given PE sin theta torque P cross E will be equal to 0, okay, and tarvata F net will not be equal to 0. These are some points, please note down. A non-uniform electrical field, torque is equal to 0, F net is not equal to 0, please, F net not equal to 0, okay. And one more point, please note down this one, please, very very important. And please, this is point charge, please, point charge. So ఇది నాన్ యూనిఫామ్ ఎలక్ట్రికల్ ఫీల్డ్ జరుగుతుంది కాబట్టి ఈ వేరీ అవుతుంది. ఎప్పుడైతే మీకు ఈ వేరీ అవుతుందో కాన్స్టెంట్గా ఉండదు. సపోజ్ ఇక్కడ ఒకలా ఉంటుంది, ఇక్కడ ఒకలా ఉంటుంది. క్రాస్ సెక్షన్ తీసుకుంటే ఈ ఈజ్ వేరింగ్ బికాజ్ ఇట్స్ నాట్ యూనిఫామ్. సో వెన్ ఈ ఈజ్ వేరింగ్ ద వాల్యూ ఆల్సో విల్ బి డిఫరెంట్. Force will be also different because what is F? F is equal to EQ. So force will be also varying. So అందుకే force F net is not equal to 0. Torque will be equal to 0. Okay? Torque on the dipole will be equal to 0. Okay na? So in F net is not equal to 0. Net force on the dipole is not equal to 0, but torque will be equal to 0. Clear? Any doubts? This is about the story of non-uniform point charge placed in a non-uniform electrical field. Clear? So now we are coming to the most interesting topic, that is electrical flux. Electrical flux. Just like magnetic flux, electrical flux, phi E. It's a scalar quantity, please. It's a scalar quantity. It doesn't have any direction. It has only magnitude. Okay? So what is this electrical flux? See, just like magnetic flux, the number of electrical lines of forces passing through it per unit area. Okay? Na? So I will try to explain by giving some diagram. So this is XY plane and this is Z axis. So in Japan electrical flux ante number of electrical lines of forces passing through a given cross sectional area. Suppose this is a surface body. So any lines of forces given body nunchi pass avutunnayo danne electrical flux antaru. The number of electrical lines. Like magnetic flux lo the number of magnetic lines of forces passes through a given area of cross section. Now I will try to explain giving some diagram here. For example, this is a body. For example, say around side B meters. It's a square having a side B meters. Placed in XY plane. See, ikkada point gurtupeట్టుకోవాలి. In the case of normal bodies like 2D bodies, the area vector is always maybe inside and outside. It may be outside. Area vector అంటే ఏంటి? It is always perpendicular to the given body. చూడండి, ఇది area vector. Suppose this is the field direction. This is area vector. So this is the angle here. So this is the field direction. Okay? So please make a note here. These are lines, electrical flux. Lines passing through. Angle should not be with the surface. Angle should be with area vector and E. Not with the surface, please. So that is why when you are defining flux, electrical flux, we will define in this fashion. E dot A. The angle between area vector is always perpendicular to the surface. Area vector and E. So it is given by E dot A, or flux is given by mod A into cos theta, or EA cos theta is equal to electrical flux. So when theta is equal to 0 maximum, cos 0 1 kabatti. When theta is equal to 90, minimum. Because cos 90 is 0, flux is minimum. So the representation you have to show in this fashion. The angle should not be with the surface. It should be with the area vector. Okay? E and E. E dot E. This is the definition of electrical flux and mathematical formula. E is maximum and it is 0. That means when area vector and E are making angle is in same direction. E and E are in same direction. 0 degrees, cos 0. And when it is 90 degrees making, it is minimum. Clear? Now we will try to explain for this figure. So here a square is given of side B. Now I told you for two-dimensional bodies, 2D bodies, area vector may be inside or outside. లోపల తీసుకోవచ్చు, బయట తీసుకోవచ్చు. సో ఇక్కడ XY plane ఇక్కడ ఉంది. What is the area of the square? B square. So for this the area vector is outside. You can see area vector outside. That is along Z direction. So what is the flux here? B square into Z direction, positive Z. ఒకటి. ఇంకోటి ఏంటి, లోపల కూడా వెళ్ళొచ్చు. మీకు ఏం చెప్పాను, It may be outside or inside. Outside avachchu leda it may be inside. So this is answer is also right, and b square into minus k cap, this is also right. Clear? Clear all of you? So you can represent in this fashion or in that fashion. అదవుతుంది మీకు. సో ఏరియా వెక్టర్ ఇక్కడ ఎలా రాయొచ్చు? ఏరియా వెక్టర్ ఏరియా అనేది బయటికైనా రావచ్చు, లోపలికి 2D ఫిగర్ ఇది. సో బయటికైతే పాజిటివ్ జెడ్ యాక్సిస్, లోపలికైతే నెగిటివ్. బీ స్క్వేర్ ఇంటూ మైనస్ కే క్యాప్ లేదా బీ స్క్వేర్ ఇంటూ కే క్యాప్ ఫర్ దట్ ఫిగర్. లెట్ us see one more figure. Let us see one more figure. Okay. Now let us try to understand another figure. See. X. Okay. Y. And Z. For example, a body is like this. Okay. Now here area vector into the x1 plane, xz plane on the 2D figure. So it may be inside or outside. కిందకైనా ఉండొచ్చు ఏరియా వెక్టర్, పైకైనా ఉండొచ్చు ఏరియా వెక్టర్. ఒకవేళ కిందకైతే ఎంత అవుతుంది? సపోజ్ రేడియస్ ఆర్ అనుకోండి. ఏరియా ఎంత? ఏరియా వెక్టర్ ఈజ్ ఈక్వల్ పై ఆర్ స్క్వేర్. ఒకవేళ కిందకి అనుకోండి, ఇది XY ప్లేన్, కిందకైతే ఎంత? మైనస్ జే క్యాప్ ఏరియా వెక్టర్. పైకి కూడా తీసుకోవచ్చు అని చెప్పాను 2D కాబట్టి. అప్పుడు ఏరియా వెక్టర్ ఎంత అవుతుంది? పాజిటివ్ y axis అంటే j cap. So the answer is either you can take in positive direction or negative because it is 2D figure. Area vector may be top or down. Okay, j cap or minus j cap. Okay na? Along y direction because xz plane lo undi body 2D. Clear? Right. Now let us go to 3D figures. Same thing, electrical flux. Suppose if 3D figures are given, 3-dimensional figures, how to write the area vector? For example, 3-dimensional figures like 3D figures, 3D bodies, that is solid bodies. For example, cylinder is there, like a solid sphere is there. So in such figures, always please make a note, inside you cannot type please, always outside. Always area vector will be outside only. Very, very important. Okay? Always outside please. For 3D figures, the area vector dA or A, whatever thing, area vector is always outside please. Either if you take small element dA, always it is pointing outside for 3D. Whereas 2D it may be outside or maybe inside please. Please make a note of this one. Okay, clear? Right? Now after learning about the area vectors, okay, let us go for next one more point that is very, very important. Non-uniform అంటే ఫీల్డ్ యూనిఫామ్గా లేదు. ఓకేనా? నాన్ యూనిఫామ్ ఫీల్డ్, నాన్ యూనిఫామ్ ఎలక్ట్రికల్ ఫీల్డ్. ఫర్ ఎగ్జాంపుల్ యూ టేక్ వన్ బాడీ. So this is placed in not uniform field, non-uniform field is varying please. So E is varying here, you can see. So ఈ సందర్భంలో ఎలా మీరు తీసుకుంటారు ఏరియా వెక్టర్? ఫర్ ఎగ్జాంపుల్ a small area if you take dA, okay, area vector. So here you take dA is a small area and ikkada తీసుకున్నాం మనం small elemental area. Field is in this direction, okay. So here if you observe, the field and area are in same direction. dA comma A are in same direction, and theta is equal to 0 degrees. So in such cases, how to get flux? Electrical flux d phi is got by integration, please. Okay, integral E dot dA. Okay, integral closed. Okay, integral E dot dA. So integration, that is integral d phi is phi E integral E dot dA. So in such cases, when when the field is electrical field is not uniform, in such cases electrical flux is got by integrating, taking a small element dA. As you know, it is outside. You can, for 2D you can take inside and outside area vector, but 3D figure you can take always outside only. So you can take outside here, angle is theta 0 degrees. So integral E dot dA. Integral E dot dA. If it is a closed surface, you can put like this. You can put, or you can put integration like this. Where E is electrical field intensity and dA is the area. Okay, na? Right. And after learning all these, okay, now let us enter into the asline point lo veldam manam. Gauss laws in electrostatics, very very important. Gauss laws in electrostatics. So a scientist named Gauss has given very nice laws, okay, in electrostatics to solve many problems. Okay. So first of all, what are Gauss laws? See, already we have learned what is electrical flux E dot A, and area vector should be always, the angle should be always between area vector and field, not with the surface. And this is given by, I told you, mod A into cos theta, or simply EA cos theta. This is the flux. And flux is a scalar, please. It's not a vector. So it is expressed as a dot product of two vectors. Now what he says is, according to Gauss, the integral of closed surface E dot dA is equal to 1 by epsilon naught times Q inside. This is very very important Gauss law. You can apply for any figure body given. Okay? Integral closed surface E dot dA, electric field intensity into dA is equal to 1 by epsilon naught times Q inside. 1 by epsilon naught times Q inside. Very very important mathematical formula here. Clear? And as I said, how to calculate the value for 2D figures, E will be either inside, area vector may be inside or outside. But 3D always it is outside only. For 3D figure, always it is outside. Okay. Now let us try to do one problem by using Gauss laws. Let us try to do one problem by using Gauss laws. That is a positive charge infinity long wire. Okay. Positive charge. Okay. Long wire. Okay. Long wire and infinite and okate. For example, this is a positive charge. So this is infinity, long wire. Infinity. So this is a positive charge. Always the field will be away from positive charge. Always the field will be away in positive charge. As I said before, field will be away and the Gaussian surface will be in the form of cylinder. Let the length be L and radius be some small r or capital R, anything can take radius. Okay, so this is infinity positive charge or long wire. So in such cases positive charge నుంచి field ఎప్పుడు కూడా బయటకు వస్తుంది చెప్పాలి, negative charge అయితే towards. So here the Gaussian surface, this is Gaussian surface. It is in the form of cylinder of capital R or smaller radius. Now how to apply here and get the flux here? Okay, now observe carefully here the surfaces. You are having three surfaces, surface number 1, surface number 2 and surface number 3, curved surface cylinder. Now if you observe carefully, it is 3D figure. 3D figure ఏం చెప్పాను, area vector always outside. So for example, this is the surface here, ఈ surface తీసుకోండి. సో దీనికి ఏరియా వెక్టర్ ఎక్కడ ఉంటుంది, బయటికి, dA outside. ఇది కూడా ఏరియా వెక్టర్ outside. And here it is outside. Outside means you take anywhere small element outside, dA anywhere you can take, dA small element outside. So these two cases if you observe, the flux net is nothing but flux due to first surface, flux due to second surface and flux due to third surface. And if you observe carefully here, this is outside. What is the angle between this thing? What is the Gauss law? Integral E dot dA is equal to 1 by epsilon naught times Q inside. This is Gauss laws. So integral E dot A lo, what is this figure? E dA cos, what is the angle? 90 degrees. So since cos 90 is 0, flux 1, flux 2 become 0 both. Surface 1 and surface 2 cos 90 సున్నా కాబట్టి 0 అయిపోతుంది. What about the third one? Third flux, third surface. Third surface is integral E dot dA is equal to 1 by epsilon times Q inside. So here if you observe, dA is outside kada, dA and E same direction. What is the angle? 0 degrees. So E dA cos 0 flux 3 surface. So E dA cos 0 1 is equal to 1 by epsilon times Q inside. So ఇది ఇంటిగ్రేషన్ మర్చిపోకూడదు, ఇంటిగ్రల్, ఓకేనా? సో సిన్స్ E is constant throughout uniform, take E outside, integral dA is equal to Q inside by epsilon naught. ఇంటిగ్రల్ ఆఫ్ dA ఎంత అవుతుంది అని చెప్పేస్తానండి ఈ ఫిగర్, అర్థమైంది కదా? I'm rubbing this figure for positive charge infinity long wire. For that I am using Gaussian law, Gaussian surface and Gauss laws applying. Now for last surface what I got? E integral of dA is equal to 1 by epsilon naught times Q inside. What is inside? Charge inside that cylinder, Q kada, either Q or capital Q, anything can take. And if lambda is charge density, it can be defined as Q by L. Sometimes some people are using capital Q, you can use small q or capital, your wish. You want to use capital Q, you can use capital Q. So lambda is, I am use capital Q, okay? Well, let us use capital Q, Q by L or lambda into L, capital L or whatever thing, okay, is equal to Q. This is what? Q inside. Charge ఎంత వెళ్తుంది లోపల? Q charge వెళ్తుంది. So put it here. And what is this A? A is nothing but curved surface area, 2 pi R into L, perimeter into length. So A is nothing but curved surface area of the cylinder. So 2 pi RL, 2 pi RL is equal to Q inside. Q inside enta? Lambda, capital L or small l, whatever you can write, by epsilon naught. Therefore E is equal to and this L, ఇది కూడా L కదా, ఈ L cancel అయిపోతుంది. So E vector is nothing but lambda by 2 pi R epsilon naught. So this is the value for infinity long wire carrying positive charge by using Gaussian surface and Gauss laws. Clear? So ఎంత వచ్చింది value? E is equal to lambda, because Q inside ఎంత వచ్చింది? What is Q inside? Lambda L. For the entire cylinder please. Entire cylinder inside. Lambda L. So L cancel అయిపోతుంది. So lambda by 2 pi r epsilon naught. Epsilon naught value మీకు కనుక తెలుసు 8.85 10 power minus 12 coulomb square per Newton meter square. So like this you can derive so many things. ఇది infinity long wire in the next infinity sheet, plain sheet. Okay, అలాగే solids cylinder, solid sphere, outside, inside. Okay, and also you can draw graphs also for that one. You can draw graphs also. Okay, note down please. Clear? See here. Same way you can derive the remaining also derivations, but to understand I am deriving for you. Actually, directly formula I can give for you, because mainly your concept I am telling you, mainly it is for MSET orientation and NEET orientation. But whenever required I am deriving. For every derivation you can't, which is not IP, for deriving for 4 marks. Because we are concentrating on MSET కాబట్టి MSET problems కాబట్టి కొన్ని దగ్గర చేస్తున్నారు, కొన్ని దగ్గర డైరెక్ట్ ఫార్ములా వేస్తున్నారు. ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ సీ ఫర్ ద నెక్స్ట్ వన్ that is infinity sheet. Okay, for infinity plane sheet, infinity plane sheet that is carrying positive charge. You can see this is a infinity plane sheet, infinity paina kinda infinity. Okay, carrying positive charge. So as I said for you, infinity sheet also Gaussian surface in the form of cylinder. Okay, and from positive charge as usual always field is away. Okay, I told you before class, for positive charge field is always away, and for negative charge it is towards. It is infinity plane and infinity is going ekkada varaku veltunదో manaku teliyadu, infinity. And here also if you observe, how many surfaces are there? Surface 1, surface 2 and surface 3 curved surface. Same. అంతే కాకుండా ఇట్స్ 3D figure. 3D figure లో అవుట్ సైడ్ వస్తుంది ఏరియా వెక్టర్. సో ఏరియా వెక్టర్ dA or A, area vector dA or A, and for this one you can take any small elemental outside పైకి ఏరియా వెక్టర్. అలాగే ఎక్కడైనా తీసుకోండి ఏరియా వెక్టర్ outside. Okay, anywhere you can take on this surface. Area vector dA outside, area vector outside. So it is very clear, these are parallel. You can see E and A. What is Gauss law? Integral E dot dA is equal to 1 by epsilon naught times Q inside charge. So when you apply Gauss law here, it's only parallel. Ikkada it is coming outside, and you can see E and A are making 90. So cos 90 is 0. So this will cancel. Only for these two the value will be. ఎందుకంటే రెండు చూడండి, రెండు ప్యారలల్ ఉన్నాయి, సేమ్ డైరెక్షన్. సో కాస్ 0 1 కాబట్టి ఇక్కడ ఎంత అవుతుంది ఏరియా? ఇంటిగ్రల్ ఈ డాట్ డిఏ కాస్ 0 1 కాబట్టి క్యూ ఇన్సైడ్ బై ఎప్సిలాన్. సో ఇక్కడ ఫ్లక్స్ లైన్స్ తెలుసు కదా మీకు, ఇంటిగ్రల్ ఈ డాట్ ఏ ఇది 0 అయిపోతుంది. అంటే ఇక్కడ 3 సర్ఫేస్లు ఉన్నాయండి. ఫ్లక్స్ డ్యూ టు ఫస్ట్ వన్, ఫ్లక్స్ డ్యూ టు సెకండ్ వన్, ఫ్లక్స్ డ్యూ టు థర్డ్ వన్. ఫ్లక్స్ డ్యూ టు థర్డ్ వన్ 0 అయిపోయింది, 0. ఓన్లీ దీస్ టూ ఫ్లక్స్ అటు టేక్. అర్థమవుతుంది మీకు? సో వన్ సేమ్ డైరెక్షన్ కాబట్టి ఈ డాట్ ఏ. సో ఈ డాట్ ఏ అంటే ఇంటిగ్రల్ డిఏ అగైన్ ఏ. సో ఈఏ క్యూ ఇన్సైడ్ బై ఎప్సిలాన్. అలాగే ఇది కూడా ఈఏ, ఇది కూడా ఈఏ అవుతుంది. సో ఎంత వస్తుంది? ఈఏ ప్లస్ ఈఏ 2 ఈఏ. అదవుతుందా? ఒకటేమో ఈఏ, ఓకేనా, ఇంకోటి కూడా ఏ. సో టోటల్ ఎంత వచ్చింది మనకి, ఇటు పక్క ఇది 90 degrees 0 అయిపోయింది. సో ఐఎమ్ రైటింగ్ హియర్ 2EA. ఏ ఇస్ ద ఏరియా, ఓకేనా, ఏరియా ఆఫ్ దిస్ థింగ్ సర్ఫేస్. ఇదిగోండి ఏరియా. ఇది సర్క్యులర్గా ఉంటే పై ఆర్ స్క్వేర్ వేసుకోవచ్చు. ఓకే, ఏరియా పుట్టింగ్, ఐఎమ్ నాట్ పుట్టింగ్ ద ఫార్ములా, ఐఎమ్ పుట్టింగ్ ఓన్లీ ఏ. సో EA 2 times EA, ఓకే, is equal to 1 by epsilon 1 times Q inside. సో Q inside కూడా క్యాలిక్యులేట్ చేయొచ్చు ఇక్కడ. ఎలాగా? ఫర్ ఎగ్జాంపుల్, ఇఫ్ సిగ్మా is given as the charge density, so Q by A or sigma into A is equal to capital Q. Here Q inside, whatever Q is inside this one, charge inside. ఓకేనా, సో సిగ్మా ఇంటూ ఏ ఇస్ క్యూ. అక్కడ సబ్స్టిట్యూట్ చేయండి, మీకు ఏమవుతుంది, ఇక్కడ క్యూ ఇన్సైడ్ ఇస్ క్యాపిటల్ క్యూ పెడితే 2 times, కెన్ ఐ రబ్ దిస్ ఫిగర్ బెటర్ టు అండర్స్టాండ్, లెట్ us draw now, clear, right? So last one I'm ending. After this again I'll go to the next part in next videos. So 2 times EA, this is after after integration, please, integral dA, integral this A, EA into Q. So this is equal to, what is Q inside? Sigma A by epsilon naught. A. So what is E? Sigma by 2 epsilon naught. So this is the electric field intensity for a plain infinity sheet carrying positive charge. So like this you can derive any derivation by using Gauss laws, properly application of Gauss laws, and calculating the flux lines and knowing about the electric field in which direction it is going, away from the positive charge and towards the negative charge. And remaining 2 more are left over, solid sphere outside and inside, and after that graphs are there for that one. Okay, and after that we'll be discussing about electric potential at a point, potential difference, etc., etc. These all I'll be discussing in the third part. Okay, these all the things I'll be discussing in the third part of electrostatics. Already I told you in first part, at the ending small mistake was done regarding at x is equal to infinity, I told infinity. Once again I'm telling, please sorry for that one. In overlook I have done a small mistake there. So it is not x is equal to infinity, charge becomes point charge. Already I explained in the beginning. So that small correction, please make a note, those are watching the videos. Okay, because due to lack of time I could not edit that one. Directly I posted in the YouTube. Okay na? So adokkate correction already I have corrected for that one. Please sorry for that one. And remaining all, please learn carefully that concept what all I told in this part 2. Again in part 3 we'll be dealing about electric potential, potential difference. Okay, and remaining part solid sphere, Gaussian surface outside, inside, hollow sphere inside, outside, graphs and other things. Okay, so we'll be dealing in the next part.